Hi, in this video we're going to look at the complex number system. Particularly we'll look at the imaginary unit I and why we need it and where we'll use it. Let's start off with just an example here. Let's find a real number x such that the square of x is 9. You probably can just see an answer to this. We've got, we know that 3 times 3 is 9, so x equals 3 would solve this. But also negative 3 would also solve it, because negative 3 times negative 3 would be also positive 9. So both of these solve this equation. Let's look at example B. X squared equals negative 9. And here we'll see that there's no value for x that would solve this, as long as we're looking at real numbers, because no number squared is negative. No real number squared is negative. So for this we'd have to say there is no solution. At least in the real numbers. Now, we would like to have a solution to an equation like this, and so we invent one. In particular, we break it down to the simplest equation of this type, where x squared equals negative 1. And we say, okay, let's create something that satisfies this equation, and we call that thing I. So the imaginary unit that is I is a number such that its square is negative 1. I squared equals negative 1. Practically, we typically use the square root of negative 1 equal to I. So where we see a negative square root, we will write I. So if I squared equals negative 1, then I would solve this equation, x squared equals negative 1. What would solve this equation, x squared equals negative 9? Well, we'll be dealing with both a plus and a minus. And since we know that 3 times 3 is 9, and we know that I squared is negative 1, one of these solutions would be 3i, because 3i times 3i would be 3 squared, which is 9, and then I squared, which is negative 1. So this becomes negative 9, and so this 3i is then a solution to this equation. And we also have the other one. We have negative 3i. Squeeze that in right here. Negative 3i squared would also give us negative 9, kind of for the same reason. If we multiply negative 3 by itself, we get a positive 9. And then I squared is negative 1. Okay. This imaginary unit can be used to simplify terms where we have the square root or an even, well, actually a square root of a negative number. The way to do that, so let's say with the square root of negative a, where a is a positive number, this becomes square root of a times I. And the way we simplify this is to write this as the square root of negative 1 times the square root of a. And this is just a property of square roots. The square root of negative 1, that's the I, and then the square root of a is left over. All right, now this I times the square root of a, if we square it, we will get I squared, and then square root of a squared. I squared is negative 1, and the square root of a squared is a. this is the part under the radical, and so we can see that this I squared of a is the square root of the opposite of a, negative a. Okay, so let's practice this. Let's practice taking the square root of a negative number and writing it in terms of I. Here I have 3 examples. We're going to evaluate and simplify. First up, square root of negative 36. Okay. The very first thing we want to do is recognize that when you're taking the square root of a negative number, that must immediately be rewritten in terms of I. So we will write this as I times the square root of 36. Right, in the same way we have right here. Now, we'll take the square root of 36. We know that 36 is a perfect square. 36 is 6 squared. So the square root of 36 is 6. So we'll have 6i. So the square root of negative 36 is 6i. Okay, just one comment about notation. If we have a radical in our expression, we typically write that after the I. And if we have just a number, like an integer or decimal or something like that, we would write that in front of the I. And the reason is, if we put the I on the right-hand side of the square root, perhaps like this, it could be confused as being under the square root. And we don't want to confuse the reader by having that possibility of a square root of an I. So this is just the typical notation. We'll put square roots on the right-hand side and then integers on the left. Okay, let's keep going. So we've got the square root of negative 12, right? Again, we're taking the square root of a negative number that must immediately be rewritten as I times the square root of 12. And then we should always simplify a square root as much as we can. Here we'll look for perfect square factors of 12. 12 itself is not a perfect square, but 12 does contain a perfect square factor, 4. 12 is 3 times 4. So what we'll do is we'll write this as I times the square root of 3 times 4. And then using the properties of square roots, we can write this as I times the square root of 3 times the square root of 4. Now the square root of 4 is 2, so we'll have 2i square root of 3. So the square root of negative 12 is 2i square root of 3. All right. Last example here, the square root of negative 18x cubed. All right, same thing. We have a negative sign here, and depending on the sign of x here, we have to assume that x is greater than 0. Equal to 0 would also work. Okay, if that's the case, then the part under the radical will be negative, and we will need to include an I. So we will rewrite this as I square root 18x cubed. And in the same way as the previous problem, we're going to look for perfect square factors of the part under the radical. 18 has a perfect square factor, 9. X cubed also has a perfect square factor, x squared. So what we'll do is we'll write this broken apart, just like we did here, factor it. You could even factor this, you could factor the x cubed as well if you like. So we have square root of 2 times 9 times x squared times x. Okay, and the reason I wrote it out this way is because I've identified now the perfect square factors. We can go ahead and write this as I square root. I'm going to put the 2x, leave that alone, and then we'll have the square root of 9x squared. Okay, now the square root of 9x squared is 9x. So we'll have 9x, sorry for speaking, 9x I square root of 2x. Okay, assuming that x is greater than or equal to 0 in all cases. Okay. What we'll do now is we are going to take the imaginary unit I and we'll multiply it by real numbers and add real numbers to it to get a whole new number system. And this new number system, the complex number system, will allow us to solve quadratics for which we may not have had solutions before. All right, so stay tuned for that.